good.
Okay, hi everyone. I'm Jonathan. I'm a postdoc with Marshall Lynn, and I'm here to present Geraldine Fauville. I'm sorry, my French is terrible. Marcia couldn't be here today, but so I'm going to introduce her. But Geraldine is a student at the University of Gothenburg, and she has been working with us for, when did you come last year? September? Was it all the way back then? Yeah, so she was with us for a whole year doing research, and she's had a lot of experience working in the area of marine ecology, marine biology, creating resources for students. She was working with Stanford before this, Stanford, and then Monterey Bay Aquarium, right? And so now she's working with us, and she's been a great opportunity for us to work with Marcia's technologies and her interest in marine ecology, and we've came up with some pretty cool projects, I think. Should we talk about some earlier stuff, right?
Yeah.
But Geraldine?
Yeah, thank you, John. So I'm not going to talk about thank you. So I'm not going to talk about what I've been doing here, but more what I'm doing in Europe and in connection with the US. And I'm going to talk about the concept of ocean literacy and marine education in the classroom. And I would like to know who have heard about the concept of ocean literacy before? Okay, cool. Anyway, you're going to know everything, or almost everything about it soon, so that's good. So during this talk, I would like first to try to convince you why we need marine education in school, and then we're going to discuss what are the challenges and some of the responses. And then I'm going to spend most of the time talking about technology we've been developing with the University of Gothenburg and Stanford University and some of the research that we've done. So let's start with the need for marine education. The ocean supply roughly 50% of the oxygen we breathe, 15% of the protein we eat. A lot of medical compounds come from the ocean. You find like marine substances in everything you use. It also regulates our climate and everything. So basically, the ocean is impacting us all the time. It's really, it doesn't matter like where you live, inland or by the coast, but the ocean is really essential for our sustainability. We benefit from a lot of goods and services that are really important for us. But as much as this is important for us, of course, we destroy it. So we, overfishing, I don't know if you can see really well, but overfishing, we pollute, we change the chemistry, the level of, the acidity. We also use the oxygen in the water. So we are basically destroying one of the system, the ecosystem we are the most depending upon. And so, of course, we need a bottom-up, top-down approach with a policymaker taking steps to make the way we use the ocean more sustainable. But since our everyday action impact the ocean, we as citizens, as individuals, we also need to have enough understanding of the ocean so we can have a better behavior in order to restore as much as possible the health of the ocean. And so we need ocean literate citizen. And an ocean literate citizen has knowledge regarding the ocean, can communicate about the ocean in a meaningful way, and can take responsible decision regarding the ocean and its resources. And later on, I will tell you where this definition come from. So that's what we need. But is it what we have? So, I don't know if some of you have seen this movie. It's called Mermaids, the Body Found. It was aired on Animal Planet in 2012. On this movie, you can see Dr. Paul Robertson from the NOAA Fishery Department telling you everything about this body they found. The problem is that this guy is actually an actor. I don't think there are a lot of doctors that actually have pages on IMDb. So he's an actor, and at the end of this movie, you actually have a disclaimer saying that it's not real actually. It's a mockumentary. The problem is that this movie fooled millions of people, and here you have some of the tweets that were online when they aired the movie. And it's funny, but it's actually pretty scary to see that so many people have so like total lack of understanding, basic of understanding of the ocean, that they believe it could be true. And it went to a point that the National Oceanic and Atmospheric Administration had to release a statement saying that it wasn't true. So that was the first movie in 2012. They released the second one in 2013, and exactly the same thing happened. That's really disheartening. I don't know if you've ever seen this map on Facebook. It was so popular on Facebook. And people were claiming that it was, after the Fukushima accident, that it was the radiation coming all the way to this coast here. So pretty dramatic. And it was really like all over the place on the internet. The thing is, this map has nothing to do with radiation. And if you look at the scale here, normally people should check scale, but they don't. It's in centimeters. And it's actually just a map of the wave height after the tsunami. So nothing to do with radiation. But again, plenty of people were fooled and scared to death because, you know, all our fish is gonna have 3 eyes. So basically, people don't know a lot about the ocean. And if we want people to take action and responsible action, they need some kind of knowledge. So they need some education. And the US and Europe have this long tradition of using formal education as a means for social changes and reform. So that's something that we should be using. We should be using formal education to teach about the ocean. But of course there are challenges and responses that we can come up with. I'm going to talk mainly about the situation in the US. I'm going to go briefly in Europe and around the world so you have the global picture. But around 2002 in the US, there was almost, I think none of the school science standard in the 50 states covered anything about the ocean. Some teachers were interested and would teach something about the ocean, but there wasn't any like kind of framework for them to work with. Also, the ocean scientists were not involved in education, and there was like almost no incentive for them to do so. So there was a community of marine educators that kept like complaining about the lack of ocean in school. And every time they were answered by, okay, but what do you think people need to know about the ocean? And the problem is that there was no consensus about what should be taught in school. So this group of people decided to gather some important actors, stakeholders, and try to address this question. What is it that people should know about the ocean? So they were really intentional about who they invited to join this effort. Because they wanted to have like a large representation of agencies and stakeholders. So they work with the Center for Ocean Science Education Excellence, it's called COSI, and they represent partnership between a research university and informal science institution, and you can see some of them there. The National Marine Educators Association was there linked to more than 1,000 teachers in the US, of course already interested in the ocean. They work with government agencies such as NOAA, and also NGOs like National Geographic. So they all work together for a very long time to try to decide what ocean literacy should be, what it should look like. So they came up first with a definition. So ocean literacy is an understanding of the ocean's influence on you and your influence on the ocean, as I already said. an ocean literate citizen has knowledge, can communicate about the ocean, and is able to take responsible decisions. So after this definition, they had to think about what are the knowledge that people should have. And they decided to reach for the end of high school. So what is it, what kind of knowledge should a student have when they graduate from high school? And they came up with these 7 big ideas, and it's called the 7 principles. And under each of these principles, you have a series of concepts, like smaller ideas. And they published the definition and the concept and the principle in this brochure. I just have one, but I can provide more if you're interested. I'm sure you are. And here you can see the 7 principles, and then underneath all these concepts. And this leaflet became a really good tool for them for like outreach and making people aware of this new ocean literacy movement. They went to plenty of conferences to present it, but the thing is, if you meet a teacher, you convince this teacher that ocean literacy is so important that you need to teach it in your school. Teacher needs something more practical. Like, for example, a 3rd grade teacher wanted to make sure that his or her student at the end of high school will understand that there is one big ocean. This teacher will wonder, what is it that I need in 3rd grade, I need to teach my kids to make sure that along the way they will build up enough ideas or knowledge to understand this concept. So the ocean literacy community started to build this concept map where they actually, everything is available online, of course. They start from this principle, and then they break it into small, like, IDs for each grade, so that the teacher can look and see, like, okay, I have to teach about this in 3rd grade, for example. Okay, then in 2010, the National Academy of Science starting to draft the NGSS, and you know much more than me about NGSS, I'm sure. But when they released the first draft, the National Marine Educator Association, along with the ocean literacy community, looked at the draft. And they were really disappointed to see that the ocean was nowhere to be seen. So they wrote this really long answer, and that's just one of the sentences. There is an overwhelmingly terrestrial bias stating that animals need air to survive, describing decomposition as a process that takes place only in the soil. So those comments were sent to the National Academy of Science, and at the second version there was some kind of improvement. There's still a huge bias, but it's better. That was something very positive. Then, right now, they're actually working on another tool that is very important for teachers. It's alignment between the ocean literacy 7 principle and disciplinary core IDs of NGSS. And they came up with a scale from 1 to 4. And when, for example, when a core ID is like exactly what you can find in the ocean literacy principle, then you get a 1. And then if the core ID can help you to understand one of the principles, you get a 4. So again, it helps the teacher to be able to teach about the ocean while, meeting the requirement of NGSS.
So who's putting this out? The ocean literacy people?
So it's this community. So the thing is, they want credibility but not credit. So it's a new website. It's not on one institute website. It's on oceanliteracy.com or something like that. So if you just Google ocean literacy, you're gonna find it. Okay, so
sorry, how do people have access to, how do people know that this exists, right? On an NGSS website, teachers go to NGSS all the time trying to make sure they're doing what they're doing, or at least as researchers we do. how are people getting the word out that there's this tool out there that the teachers can use to help them
Yeah.
figure out how to put ocean literacy?
So with presentation like this one, basically. So the community has been really active with this leaflet and all their tools, like going out to conferences, science conferences and education conferences to present this work. I'm saying that, I'm from Europe, and I say that maybe 30% of you know what ocean literacy is, so there is still a long way to go. But there is nothing on the NGSS website actually about it. It's on a separate one, so you need to have some kind of knowledge already to, reach that information. So that's a very good point. So, as I said, they have presented, like all those partners have presented at various conferences, both now, when you have an ocean science conference, you often have an education strand, which is pretty new. So that's kind of, one of the consequences of this community. Also, some of the funding agency requires ocean literacy principle alignment for funding, which is also amazing. And then they inspired other regions like Europe, and I'm going to briefly mention Europe because it's where I'm based, and I've been really active in the ocean literacy movement in Europe. So we started with ocean literacy almost 10 years after the US, and the situation was also like no ocean in the curriculum, no incentive for scientists to do any outreach of education. One major problem that, it's also a strength, but in Europe we have so many different languages that it's very difficult when you have learning tools in one language to make it usable all across Europe. We have so many different curriculum. It's not even by country, it's by region most of the time. And also, although there are marine educators in Europe, there was a huge lack of network between everyone. So in 2011, with a colleague from Belgium and UK, we founded the European Marine Science Educator Association, MC, so the equivalent of the US National Marine Educator Association. And we try to promote cooperation between marine educators. We work a lot with policymakers to advance ocean literacy because we were, like in 2011, we were way behind the US. We try to raise educator awareness about the importance of the ocean, and we also work a lot with marine carriers, which is important in Europe. In 2011, we had the first conference on ocean literacy, so we gathered a lot of stakeholders to just know what ocean literacy meant to them and how we could have a European version of it. It was a timely event because the European Commission, basically the equivalent of NSF in Europe, the Commission was drafting their call for proposal for the next round, and they were really interested in ocean literacy. So we helped them actually to build their agenda related to this issue. And in relation to that, now we have two funded projects. These are 3-year projects with like 10 countries involved, and it's the first time we actually have money allocated to ocean literacy in Europe. And although it started like late, since it really happened at the right time when the European Commission was willing to give money, we are actually really catching up with the US, where there is less and less money for ocean literacy. That's too bad, because then we can't really work together, because there is always money on one side but not on the other. There is also an association in Canada and an association in Asia, so it's going totally global now. It's not just an American project anymore, it's all around the world. So now, if all these associations help to bring more ocean in the classroom, it's a really good thing, but it's just part of the problem. So when you want to teach about the ocean in the classroom, you have many different problems. Most of the phenomena happening in the ocean are way too big to be experienced in a classroom, or way too small. or the ocean is far away if you live inland, or even if you live by the coast. It's really difficult for a school to bring the kids to the shore because of safety, funding, whatever. And finally, even if you go on the shore, you just see the surface of the ocean. So these are some of the problems when you want to teach about ocean literacy in the classroom. So one solution is to look at technology. And technology started in the 1920s in the classroom with radio and television, and then it was computer, internet, and now it's virtual reality. And there are a lot of advantages that you can read all over the place. So it increases clear thinking, interpretation skill, it helps students become expert in looking for information, and so on and so on. But despite all the research done, all the money invested, it's still pretty difficult to see a clear impact of technology on academic performances. But what is sure is that technology has changed the way we learn, how we access information, and what are our expectations about learning. So now I would like to present some of the tools we've developed for marine education in high school. And I work mainly with the marine issue of ocean acidification. So you know that we are releasing a lot of carbon dioxide. About 50% of this carbon dioxide get dissolved in the ocean, which is really good for the greenhouse effect. It's at least 50% of the carbon dioxide that's gone, but it goes in the ocean, and it changed the chemistry of the water. And it's a kind of a new issue. It started about 15 years ago, or researchers started to think about it 15 years ago. And at first they were mainly worried about the organism with a skeleton, external skeleton, the calcifier organism, because they say like, well, they're not going to be able to build their skeleton if the water is too acidic. Now they realize that it has a much larger impact than just on these species. So in 2008, I started working with Stanford University on a project that at first was called I2I. On the project developing digital technology for awareness on ocean acidification. And we've had different projects with different names, but our goal was always to help high school students to get a better understanding of ocean acidification, to realize their own contribution to the problem, and to find ways to take action. So how do we work? Well, in our team we have teachers, we have researchers in marine science and in education science. We develop, as I said, digital learning resources. They're all available online for free, and they're all designed in English. And we do some research on the implication of these resources for the students. So here's how we articulate our different tools. We want students to have some answer to three main questions. What is the problem? What is my personal contribution? And what can I do about it? So if you start with what is the problem, we have two tools, and the first one is called our Acidifying Ocean Virtual Lab. And in this virtual lab, the students first have a lesson on ocean acidification, some kind of interactive lesson. And then they run an experiment on sea urchin larvae at two different levels of acidity. And I'm going to show you a screencast so you have a feeling of what it looks like. So at first is the lesson with some interactivity. Here they can see the chemical reaction of carbon dioxide dissolving in the water. And here they have to place different liquids on a pH scale, so they get familiar with the level of acidity, or how basic liquid is. It's all liquid they are familiar with. And then the students stand in front of a virtual lab bench where they will follow a protocol. So they will raise sea urchin larvae in water with 2 different levels of acidity. And then they will raise them for 5 virtual days. And then they will measure them. And it's a drag and drop game. So here they drag a slide, they take a pipette, you don't see it so well. They take some larvae with the water, put it on the depression slide, put the cover slide, and then look at it under the microscope and you can see the larvae. Okay? Yeah, and then they measure the larvae, so the arm length, so they move this ruler, so they can measure 3 replicates from each treatment. And at the end, they measure the average for each treatment, and they can compare the data they received when measuring 3 larvae for each treatment with a larger data set. So it's a good opportunity for the teacher to talk about the importance of having more replicates. And also each student has a different data set, so they can go to each other and see that they don't have the same results, which is what happened in science. We've given some pre and post tests to the student. We show a important increase in the level of knowledge about ocean acidification, which is pretty straightforward since most of the students don't have some understanding of ocean acidification when they start. But they also have some open-ended questions. So here we basically ask them to design an experiment, and they have to write it. And we looked at the pre and post test and compared first the length of the answer, the number of words, and we can see that there is an increase in how much they write, which isn't something, but depends what they're writing about. So we also looked at how many scientific concepts do they correctly use in their answer, and we also have an increase here. We also looked at those answers from these 80 students, and we put them in categories. It's kind of a KAI score. It goes from 1 to 5, 1 being I have no idea, and 5 being pretty good experiment. And we showed that about 40% of the students actually reach a higher category in the post-test. So it seems to indicate that this kind of tool can improve student scientific way of thinking. So still about the same question, the first one, what is the problem? After the student have used the virtual lab, we asked them to look at an interactive talk from a scientist. So basically, the scientist starts from the results from the virtual lab, and which was one experiment on one species, and then kind of extrapolate and talk about how ocean acidification is not just important for these larvae, but for all of us, basically. And then it's a platform called VoiceThread. I don't know if you're familiar with it, but basically you can upload slide or presentation, and then the people watching it can post comments or questions, and then you can have some kind of asynchronous discussion. So it's what we have. We have asynchronous discussion between the students and the scientists. So again, I'm going to show you a short clip. So here's one of the slides that the scientist uploaded. Normally you can hear his voice. As he was talking, he also was doodling on the slide, which is really good when you want to explain a graph. Then the student can know exactly what you're talking about, which part of the graph you're talking about. And then the student can navigate through the different slides, jump from one to another, and then zoom in and zoom out. And the most important, they can leave comment, post comment, mainly by recording their voice or typing it. So here the student is typing, I don't understand that part of the graph, could you explain it one more time? And the student can show what she is talking about, which region of the graph. And then the question is embedded in the presentation, so the scientist can go back to the presentation later and answer the students' questions. I'm actually currently working on the data from 3 classes here in the US, in California and in Illinois. And I'm interested in, just at the students' questions. And I won't go into detail now, but I think these 2 are very interesting. Do you think the marine plants benefiting from ocean acidification could help actually absorb some of our CO2 emission, maybe help prevent greater ocean acidification overall? Sort of like the idea behind planting tree to offset. The other one is the same idea about like on the ground, the plants can convert carbon dioxide to oxygen, but the student is wondering, can the sea plant also absorb carbon dioxide? And it actually goes back to the terrestrial bias that I was talking about. These students seem to have a pretty good understanding of photosynthesis on Earth. But when it comes to the ocean, they're not sure about it. So it shows that the terrestrial bias is not just in the curriculum, it's actually transferred to the behavior and the question of the students. So yeah, good understanding of the photosynthesis on land, but not really, they don't master the same idea when it's in the ocean. So the second question we want them to think about is, what is my personal contribution? And for that we have a carbon footprint calculator. When we started the project, we thought, okay, there are plenty of calculators online, we're going to find the one that works for us. But we wanted a calculator addressing student lifestyle. We wanted it to take into account the student location, because we had at that time students in Sweden and in the US, and the same behavior in both countries will have totally different emission depending on the source of the energy. So it was really essential for us. And then it was also really important for us that the student could see the impact of one behavior when they were going through the calculator, not waiting like until the end to see, oh, that's how big my emissions are, but I don't know what it relates to. We couldn't find it, so we had to build it. Again, a demo. So first, when you log in, you have to say your location. And then there are 50 questions divided in 4 different sections: transportation, home energy and appliances, food, and personal purchases. So here's what a question looked like most of the calculator. And you have 2 bars here. The first one is the average emission per year for the country selected, divided in the 4 different sections. And then the same for the user. So you can always compare yourself to the average. And so you click on the right answer. And if you say that you eat beef 10 times a week, you can directly see that your emission is like jumping. So you understand that this behavior have a strong impact on your total emission. And then at the end, student end up with the data for his data for the 4 different sections compared to the average for the region. Students are asked then to go back and look at ways for them to decrease their emission. Also on each page, we have in-depth information about how we make the calculation. So all the assumptions, so it's really scientifically transparent. Students know where this number comes from. Concerning what can we do about it, so the last step, we've built upon the carbon footprint calculator and created the International Student Carbon Footprint Challenges. Here, the idea is for students to have an international view on this carbon footprint, to learn from each other, so to discuss with students around the world, and to envision solutions together. So we work with sessions, so every second month we have a challenge. We have students from all over the place. And so the individual students calculate their footprint, then the teacher gathers the data, calculate the average, and for each class we have a pin on the map, and in the classroom they will kind of explore them up. So that's what we were doing until last session. But actually, through my stay here last year, we started a collaboration with Concord Consortium and the CODA project. Now we have, since students have to register, we now have data on carbon footprint from 45,000 students. And we wanted to make use of it. And we decided to make all those data available for students to play with it. And with CODA, they can actually graph basically whatever they want in this huge database. So they can look at the emission for one particular question in different countries, for example. And so we just started with that, but it opens like a lot of new learning opportunities for students, both to learn about their footprint, but also about math, statistics, graphing, and so on. So after looking at all the data, we have a platform where students will have discussions. So we've created a bunch of discussions where all the students will participate at the same time. A couple that I really like, one is wants or needs. It's about like, do you really need to have the latest iPhone or do you want it? So it's really insightful actually with the students' answer. Also, what are you not willing to change for the sake of the environment? So really interesting discussions happening there. Okay, so what I've done here is I looked at one of the online discussion, and the prompt was, did you identify an area in your life that you can make changes? Are you willing to make those changes? And I looked at 28 posts from a student in the US and 5 in Europe. And then after this challenge, this activity, the student received a questionnaire. I looked there at 2 questions from almost 800 students. The first question is, after participating in this project, are you more likely to take steps to reduce your carbon footprint? And the second one is, how seriously an environmental problem did you consider climate change before or after the project? So I'm gonna show you the kind of structure we could find in these posts, what the student posts online. So first, they always try to estimate how they're gonna do compared to the average. So for example, I took the carbon footprint test thinking that I'm going to get a low percentage compared to the average. So this person was expecting to be lower. And then they compare their results to the average. So I was a bit shocked when I saw that my footprint is a bit over the average for Croatia. And it's interesting because we see a lot of, I was glad to see, I was shocked, I was embarrassed, I'm surprised, and so on. Then after realizing that, you know, this difference between them and the average, they kind of account for it. They try to find an explanation, and they can do that because on the calculator, they could see for each behavior how much emission it was linked to. So here it's probably because I took a trip to Spain by plane last year. Then all this kind of guide their future behavior, their idea about how they could change. And here this student is suggesting to try to carpool to these football games. And finally, they kind of step back from this really like individual perspective, and they look at, you know, the global picture with comments like, if we change this little thing in our lives, we can make a huge impact on the world and our carbon footprint. When we look at the questionnaire, so the first question was, how serious an environmental problem do you consider climate change before and after this activity? And you can see that we have an increase in how serious the students take it. Then we asked them if they are more likely to take steps to reduce the carbon footprint after this activity. And 90% of them say yes, and it's anonymous, so they don't have to say like, oh, I know that's the correct answer because there is my name there. So what we see is a lot of emotion associated to the online discussion. So if the student emission is above the average, then there is some kind of guilt. And there are a couple of papers showing that this guilt is actually kind of triggers a willingness to have more mitigating behavior. There is also the other side, pride. So people that are lower than the average. It seems again that it's also motivate positive, like it reinforces pro-environmental behavior. So it's really good to play with their emotion. Then we have a lot of I had no idea. And actually carbon footprint is a new concept and it's totally invisible. So it makes total sense that students have no clue where they are compared to the average of the country. So it's really good that we can transform something that's totally abstract and visible in some kind of concept that they can manipulate and make more visible. Okay, so with that, my take-home message for today is that ocean literacy is an important skill in the world we're living in. It's very challenging to study the ocean in school because it's difficult to experience, and also because there is still a very strong terrestrial bias in the curriculum. Technology can be one of the solutions to experience the ocean in ways that would be impossible otherwise. And as I am a marine biologist, I also think that technology should not replace any real encounter with the ocean. If you can get your feet wet, you have to do that. And with that, thank you very much and happy Halloween! Any questions?
So you talk about like the curriculum, and there's kind of this absence of ocean literacy in the curriculum. I mean, how do you like reconcile this tension of, well, now you gotta teach about oceans? It's like one more thing to like add to an already overwhelming task of trying to teach these kids about everything.
Yeah, so it's not about adding anything to the curriculum. I totally agree with you. All the teachers have like way too much to do. It's just changing the example you give. So if you talk about photosynthesis, instead of taking 2 terrestrial examples, you can take one in the ocean and one on land. So, and that's also why this alignment between the ocean literacy principle and the NGSS is so important. It means that you can reach your goal by taking some ocean example instead of the terrestrial. It's like, you know, saying like everyone learned that forests are the lungs of the planet. Well, that's not true. So it's not about adding anything, it's changing the way you teach it. Yeah, it's just one way to do it, and we have had this like tradition of using terrestrial, and it's just, you know, shifting the thinking to the ocean. Yes.
One of the problems I think some people have found in translating carbon footprint sorts of items to students is that they don't have the financial wherewithal to like sell their family car and things like that. Did you find that as a challenge also, that they were torn between answering for themselves or their entire family?
Okay, that's also something that was the first point that was important for us, is have question concerning behavior that student can change. So we don't ask about the car. Like we ask how many kilometers to go to school, do you take the bus? But we want it, or we don't ask like how much is your electricity bill, because they're not going to check. So we really trying to ask questions about behavior that they could change if they want.
What role, like I'm wondering what role do aquariums play So on one hand, they're they're sort of damaging the ocean life, but on the other hand, they can play a big role in an educational sense. So, you guys, have you looked at that, or?
Yeah, so I work with formal education, so I'm not looking at aquariums and museum and science center. The tool we have are too long to be implemented in aquarium settings because you need activity that takes 3 minutes or something like that. But it's a big debate. It depends on the aquarium, what their business is, so they need to make money. I think they're getting much better at promoting education. I also believe that seeing an animal for real has give you a connection to the ocean that you won't get, but not the same way if you watch it online. And I don't say that captivity is a good thing. I just say that there are pros and cons that are extremely hard to weigh, and so I work with formal education. Safer. Yeah.
So, I don't know if it was the same item or if it was a couple of different times. The students were asked about their footprint, and then they were shown values to compare them to other people in their country or their region or whatever it was. And so you could see how a student who saw that they were much higher than the average would hopefully go, oh my goodness, I'm so much higher, I should change my behaviors. But even a student who's going lower than the average, right, in certain regions, that's not saying a ton. And there's obviously so much more that we all need to be doing, even those of us, if you're maybe on the lower end of that spectrum, right? So are you trying to, so is there ways for them to access, so we asked you about these things, but here's even more you could be doing? Because it seemed a little bit okay, good job if you're under the average.
Yes, so first of all, if you want to really be happy about yourself, if you want to have a sustainable emission, you need to reach 1,000 kilogram per year, which is basically impossible for us. So we had a long discussion, do we want to tell them okay, you're below average, but still pretty bad, because if you want to be sustainable, it's 1,000, but then it's too depressing,
Totally.
because it's impossible to reach. So we make it clear that it's below the average of their country, but it's still not sustainable. So we're not saying so they are saying oh, I'm glad I'm below the average,
Right, and then I feel it's okay, good job.
Well, it's actually not. So they're still pretty good at looking at what can I do and also, since they're all on the same platform discussing with each other, they're really good at giving advice to each other. So for example, it's oh, I was really happy I'm lower, but I don't know how to go even lower. What can I do? And then another student would say well, you could stop eating meat 5 times a week and go to 3 times a week. So they're really good at giving advice to each other. So I don't think we really had students, or maybe some, but the feeling was not really oh, I'm good enough, that's fine. So they were still they had this understanding that the way we all live together is not sustainable in any way.
I wonder if maybe you can say, compare it to the average, but then say, okay, your goal should be to reduce your footprint by this percent. What could you do if that can kind of help with that?
Yeah. Yeah, that's an idea. What we did also is show them the average of their country, which most of the time is industrialized country, so it's pretty high, and then average of the world, which is much lower. And we say also is there any way for you to kind of reach this point? So, but yeah, asking to decrease by 1%, depending on how high they are, would be a good way to do it as well.
I'm curious, it seemed
just, at least from the way you presented it, that the ocean acidification was kind of a motivation for talking about the bigger issue of carbon footprint. Is that the focus, or is it like carbon acidification is one issue related to ocean literacy? I guess I'm almost wondering, is the focus on reducing carbon footprint, or is the focus on ocean literacy? And if it's on ocean literacy, then is there a reason that it has to be oceans and not like global water systems? Because I'm trying to think, like, I grew up in the Midwest on the Great Lakes, so like I hadn't seen the ocean until I was 20, but I grew up on these lakes, and like there's a ton going on there, but it's different issues. It's still, it's like.
So first, after the ocean literacy principle, now you have the Great Lakes principle, or Great Lakes literacy, so it's also a thing.
Yeah.
Can you repeat your question?
Yeah, sorry, I rambled there.
No, right. No,
I guess I'm
okay, I
curious.
remember. Yeah. So the thing is, ocean literacy is not isolated from the other literacies, and NOAA actually placed it between at the intersection of science literacy and environmental literacy.
Okay.
So it's kind of part of both. You need both of those aspects. You need some critical thinking, ability to read a graph and understand how science is, produced, and then also some kind of caring about the ocean or the environment in general. And I think what's really interesting with ocean acidification is that it's not just about the ocean. It's about the carbon dioxide affecting the atmosphere and everything that lives on land and then in the ocean. So it's a way to link climate change and ocean literacy. And climate change is really, well, we can't really say debated because it's not a debate anymore, but it's invisible. It's easy to kind of, try to deny it. With ocean acidification, you measure the pH, it's dropping. So it's really easy then it's easier for students to understand that yes, there is something happening that is visible on a graph, rather than the average temperature. Like climate, just the concept of climate compared to weather is so difficult for them to understand, and it's over such a long period of time, and that senator coming with a snowball and saying, see, climate change doesn't exist, you avoid that kind of problem with ocean acidification. So it's another way to access the idea of carbon dioxide problem.
I think what prompted it was your very last point, like there's no substitute for getting your feet wet, is that it seems like there's probably like motivating local examples that could be, like growing up we could have looked at the zebra mussel invasion and how anything that goes in the lake comes out covered in zebra mussels. Like that's pretty interesting too. So thinking about getting that first-hand experience through more localized examples.
Absolutely. Yeah. It's just that every time I present, people tell me like, oh, so you don't want people to experience the nature anymore? You want them just to be in front of your computer? No, it's not about that. Not at all. Something else? So what is your experience concerning teaching about the ocean in science in the US?
I mean, I grew up in South Florida, and so they talked about the ocean all the time. That and the Everglades, actually more the Everglades than the ocean. So it's actually interesting to me because that was a large part of my education, and I hadn't realized it was an issue because we talked about it. Though we didn't talk about it from the global warming perspective. It was more look at all the cool animals in the ocean, and pollution is bad. It's interesting, but it makes sense that it would be a particularly unique environment in South Florida where there is so much water, and where the ocean is we get hit by hurricanes and stuff. The ocean is very important.
Yeah. So that would be interesting. So I've heard that there wasn't any ocean in the 50 states curriculum, but maybe in Florida it was actually in the curriculum.
Possibly.
Yeah.
It would have been that I happened to have a teacher who taught marine biology as an elective. Yeah. But the fact that most schools have marine biology as an elective probably says a decent amount.
Yeah.
Or maybe not most, but a lot of them.
Yeah. That's really interesting. Yeah. You can definitely learn a lot from a place where the ocean has been in school for a longer time.
At least in my school, I
Yeah.
don't know, yeah, I found that interesting.
Any other experience? Yeah.
Well, not experience, it's more like a question, and it's related to the last thing you said about getting your feet wet. And I agree completely with that. So I'm guessing that maybe in some schools, some people might use doing the computer thing as a replacement, like the easy way, even though they have the resources to do that. So I'm just like wondering, what would be your thoughts about how to take like children to nature, ocean, or whatever, because I know it's super difficult, like to transport, like all the things you mentioned, like security, maybe they don't have the resources, but I'm guessing you've thought a lot about this, so I don't know, anything that comes to mind.
So there is an interesting paper, it's about environmental literacy and technology, and there is some discussion between two teachers, and one said to the other one, oh, we just received the CDs like about like whatever environment, and we could use it in the classroom, and the other one say like, oh, well, but why don't we go and, you know, visit that environment? And the first one said like, oh, but it's easier, you know? So yeah, that's definitely a problem. Also, I think some teachers might be like that, but I think the main problem is more, as you say, like funding and safety. And I don't think there is any easy solution to overcome these massive issues. I mean, then you have to go to like governance level. It's not at the school level or teacher level. It's like much broader. And I don't know how to change that. So yeah, so it's a risk. It's definitely a risk.
I just remember as an elementary school student, maybe second or third grade, we went to the tide pools. I'm from the South Bay, so we took like a field trip on a bus and went to the tide pools, and I definitely do not remember it being safe. Like, definitely we were on rocks and touching starfish, and some kids were falling in the ocean, but we all remembered it. No, I mean, no one was lost, I'm just saying. They really wanted us to just touch things and squeeze pickleweed and do all of that, and I just remember that being extremely positive for me, and I can still remember that particular field trip. But I don't think it would have been the same if the conversations we had in the classroom were not coupled with the ability to like squeeze pickleweed or whatever. So like it's a little bit funny, people getting their shoes wet or falling in the ocean, but that's what you do at the beach. Like that's what you do when you interact with the ocean. You get wet and you get salt in your eye or whatever. So.
It's how you make people interested in anything.
Right.
It's by, connecting to their emotion. We have fun and,
Yep.
and you remember, and then you carry on this fond memory, and then you want to care about the ocean.
Yes.
But as you say, kids falling and parents being worried and,
It was the 80s, we survived.
Yeah, sure. Obviously.
Yeah.
It's natural selection.
Yeah.
So kind of along with that point, it would seem, so these 7 principles are kind of geared toward, by the time they finish high school. But to me, it seems like a really effective strategy would be to start in primary school, because that's where the imagination, the enthusiasm, like the fun is still like very much present. By the time they get to high school, not to say that you're starting them, but if the focus of the principles is by high school, people tend to focus on the end as opposed to, okay, we really want to target elementary because, when we talk about understanding our world, we have, 7 oceans, maybe 6, 7, however many oceans there are supposed to be, but now this is one ocean,
Yeah.
right? And so it's those early ideas where I think these principles would be much more effective. And then, because I remember for a long time I wanted to be like a marine biologist, but as I got older and that I didn't live around, you know, the ocean, it became less of a realistic proposition, whereas when I was younger, that still captured my imagination. So are there efforts to like put a lot of focus on
So the idea of the principle is how much you should know by the end of high school, because normally everyone goes through high school, so it would mean that all the adults will have this understanding of the ocean. But they've created, I show it, but maybe it wasn't clear enough, like those conceptual maps for each grade, with like what ID you're supposed to teach the kids in first grade, second grade, so that they can build their understanding all along the way, and at the end know everything that's here or have an understanding of it. So yeah, the idea is not at all to focus only on teaching high school students. It's like for everyone, and it starts with like tiny small ideas, and then it grows bigger and bigger. Yeah. Yeah.
Yeah, I mean, I understand it's like, you know, for everyone and everyone should get it, but if a lot of effort were focused on the very beginning, I feel like there would be more bang for the buck.
But there are a fair amount of marine educators and marine projects that specifically target primary education or lower grades. So I think there is a fair distribution. Yeah. Yeah.
So you talked about showing how the 7 principles line up with NGSS. And I was wondering, are you guys planning on developing any curriculum? Because I think with the school switching over to NGSS and teachers in the need of curriculum, if you supply them with curriculum that that aligns with NGSS, because I think I agree with you. I think it's sometimes as simple as choosing specific examples to incorporate it. But I think that would have a large impact too, because teachers are going to be in need of that curriculum right now.
Yeah, so the people aligning NGSS with ocean literacy is this like broad community, so different organization all together. But each of them individually provide curriculum. Yeah, like the Lawrence School of Science have a lot of projects and programs with marine science for all grades. And now, you know, it was aligned to the former curriculum. Now they are like adding some information to show how it actually aligned to NGSS. So yeah, I think like there are a lot of curriculum available, and one of the important step for all those projects is to show how it now aligns with the new curriculum. So yeah.
Something else that I noticed is in the map you showed us, there was only one point for Latin America. So I was wondering how schools get involved in the project. It's really interesting if you have data from all over the world, but it was not only Latin America, it was like Russia and like that side of Asia. So how do you think you could involve people all over the world to have like a more comprehensive set of data?
So we definitely have a bias toward the US and Europe, because we have a team in US and in Europe, and it's all about personal connection. So in ocean literacy, I have some colleagues in South America, Latin America, but you know, it's all about human connection. Unless I go there and work there 6 months and build a network, or you help me, it's difficult. So we are really trying to reach out, going to conferences and presentation. Like we literally spend hours online going through all the international schools all over the world and contact them. But again, it's just an email from someone they don't know. So, and also we have the language barrier. Everything like these discussions are in English, so we also have problems to reach like France, for example, because it's not every teacher is fluent in English, and you first need the teacher to be able to understand what's going on, and then the students. So yes, so if you could help, that would be great.
I might know some people.
Okay,
that
nice.
can talk to you.
Well, thank you very much.
Thank you.